Hello, everybody. I just deactivated the waiting room. Clicking on everyone with a waiting room can be a lot of work. Good. Good. Then let's get started. And Denise, you mentioned that you had a couple of new exciting user timing actions.
Yeah.
Show us today.
Yeah, I've mentioned that, and I'm super excited about both of those. Even though one of them is not pushed to master yet, but you will get the sneak preview now, and it's gonna blow everybody's mind. That's how I want to advertise this. So, but we'll start with the simple things. So, first of all, I'm happy we get yet another performance session. This is so exciting. Now, let me just mention, first of all, about a couple of weeks ago, I think, we've merged the Vue performance plugin into our code base. What does it mean? It means that now we can measure user timing metrics for our Vue components without, like, with as little effort as possible. So let me just share my screen now, and I'll show you the thing. Wait a second. Is it this one? Yeah, this one and this one. Yes. Okay. So we'll get back to this one. Let's do this one. So do you see my screen now? No, you don't yet. Now you should. Yes. So this is the merge request that introduced the Vue performance plugin. It's super simple, super trivial, yet it does the job as it should be. So technically, we just import the plugin. I'll increase the font size so that we have things. We import the plugin, and then we just use it, specifying the components that we want to measure. There is one catch there, that the components you want to measure have to have the name option specified. That's and you can get to the conversation of why this is important in this merge request. But technically, this is just adding name and then the camel-cased name of the component to your components, or to the components that you want to measure. And then it will automatically measure the start of the bootstrapping of that component and the moment the component got rendered on the screen. So we are using the before created hook and the next tick within mounted hook. So if you have the performance bar enabled, you will get all sorts of things. So for this example, I'm measuring performance of 3 components. And this is what you get in your performance bar developer tools output. So all of the components get measured. You get the marks and you get the measurements for all of those components. Keep in mind, though, that this plugin doesn't wait for all the sub-components to get rendered. So if you are, for example, saying measure the moment my IDE application gets rendered, it won't wait for all of the tree components and editor component and terminal component. It will really be fired in mounted. And as most of you probably know, mounted doesn't wait for all the subcomponents to be done. So that's something to keep in mind. So if you want to measure the performance, for example, in this particular case, I'm giving the example of measuring performance of the IDE application, and I don't wait for the IDE application. I measure the IDE tree list. This is the performance of the navigation tree. I measured performance of file tree. This is going to be the first rendered tree item on the screen. And this is what we care about in WebID, because this is the moment that we can say, okay, the rendering has really started. And the repo editor, it's the editor for the file. So in case you get to WebID and request a particular file right away in the URL, for example, README or I don't know, changelog or anything. So when we open the editor for a file right away, this is going to be component that is fired, and this is going to be component that gets measured. So you can, as I said, you can measure or observe it with performance bar right away in the DevTools. You can observe it in your DevTools, and obviously you can get all the way to the core and just query those metrics in your DevTools. So as I said, this is the WebID. Unfortunately, I cannot demonstrate. Oh, actually, I can probably demonstrate it on GitLab. This is going to be fun. So we go to where is our, well, any project really. So we go to the WebID. We open the DevTools somewhere. Where are my DevTools? Hello. Yeah, here we go. Let's have those on the side. So if we enable the performance bar, so here are all my metrics output right into my console. This is not very, in particular for the WebID, since we have a lot of performance issues with WebID, there are a lot of metrics there, but normally you should not have as many metrics, like unless you really know what you're doing. And if we run the performance profile in the profiles tab of the DevTools, you will see nice blocks indicating the duration of any of these measurements. For example, like every component's life cycle duration. It's really convenient. It's really nice, and gives the idea. And like, if we render the performance profile now, you will notice, yeah, if this ever happens, the obvious issues with the performance in WebID will be very obvious. So yes, let's zoom into this thing. So we just do things in sync. So we fetch project data, then we fetch branch data, then we fetch files, instead of doing those asynchronously at the same time. This is, we already have the issue for this. This is what I'm going to work with. And this gives a really good overview of what is going on with the things. And here is, in the merge request, I give the example of 3 components being measured, but in production, it's fine for me to go with just one component, that is file tree. Again, this is the very first item in the navigation tree. So in this particular case, GitHub item to be output. And this is where it happens. It happens all the way at the end of the thing. So we wait for all possible things to come in, and only then we start rendering the file tree. That is not good. Just, you know, unless we all disagree in this, I have to tell this, but this is something we have to be agree on. This is View Performance plugin. So it allows you to not dive into the bells and whistles of Performance API. Just use the plugin, specify the components that you want to measure, and it will do the job for you. The question is, like, this amount of information in the DevTools is pretty overwhelming, right? So that's why we have this wonderful dashboard that is dedicated to the user timing API and user timing metrics. And that's where we have output of all the measures and all the marks. And when you see the marks like this, it's pretty clear where the things are sort of not good. So we see that some things happen here at the bottom, like in chunks, in batches, and then we wait for the whole project information, then for branch information, then for files information. So several ways of getting the information about those metrics in your application. We also, do we have any questions about this plugin now?
Do we have any performance cost for measuring, for basically printing it out? Does it really understand that it only does the things then when we have the console open?
So the answers, just to make sure I understand. So the first question was whether we have any performance penalty for outputting the things, and then whether the plugin knows that the console is open. Yeah. The answer to both is no. We don't have any performance penalty. We don't know whether console is open or not, and we shouldn't care. The way it is organized, like the outputting into the console happens not by the plugin. The outputting happens by the performance bar, right? You have the performance bar disabled, you don't have any output, yet you will still have the information. It doesn't mean that we do not measure. It means that we just don't output this information. You will still be able to get the information in the performance bar. You will still be able to get the information in the dashboard. So all that information is collected. The performance penalty is not there because this is the async API. As any, as most of the modern web APIs, this one is async. The performance, the user timing API is async. And even if you have the console open, the outputting of those is also async, because there we use the performance observer that is an async thing as well. So no, there is no cost, and we don't know about open or closed console, and we shouldn't know about that. Okay. So that's the measurement happens no matter whether you have console open or not, whether you have DevTools open or not. The measurement happens. It has zero performance costs, yet you are still able to use that information. Any other questions so far? No. Wonderful. So there is another interesting merge request in the review now that you might want to get into, and this is the actual documentation on how we use user timing API. And here we so let's close this. So here I cover the basics of what is the user timing API, how to use it, then how we actually use it in GitLab. So we have user timing API utility. This is for measuring performance in our HAML and in our Rails applications. And then we have the View Performance plugin. So you should be getting this information soonish, I think. This merge request is in review for a bit over a week now, so should be pretty should be coming to our documentation portal pretty soon. And if you didn't know, we use user timing API utility. We actually do. It's called performance mark and measure. And if you search the code base, you will find it. We will find appearances mainly related to snippets and web ID, obviously, but you will find how to use it outside of Vue applications, because the plugin we were talking about is only about Vue, and this utility allows to measure performance of pretty much anything. This is vanilla JavaScript implementation, framework agnostic, that you can use anywhere. So this is the documentation that is coming soon. The dashboard, again, just for those who are not familiar or forgot that we have this, the user timing metrics can be found. I hope they will be found over time in the future. So team did a great job of making it persistent, because for several weeks in a row, we were missing this dashboard and we had to restore it. I hope it's here to stay now. And you can add any, so we have a lot of routes already measured, but in order for route that you're interested in to be user timing metrics aware, you have to add those metrics to your views. So if you want to start measuring if you want to start getting more information about performance of your routes, but much more than just LCP, for example, then this is the way to go. Add the user timing metrics to your routes, and then they will automatically be output into this dashboard. And it supports several views, several routes at a time. So you can compare, for example, different instances. Like we have snippets textual and, for example, snippet multi-file and snippets markdown. So you can select all three of those, and they will be output 3 here. So you will see different parameters and can compare nearly side by side. It's more like top bottom, but okay. This is the dashboard. And now I'm getting to a really, really exciting thing. I'm sorry, I might sound really unnecessary, too excited, but I'm about to present a work that I started in summer. During my spare time, I was playing with some ideas of how to make. So the problem is measuring performance is never fun. Performance is it's all of your spare time. And if you want to optimize anything, you will have hard times to know when to stop. So you are like, once you start digging into this thing, you're doomed. Like, this is the Pandora's box. So I thought, okay, how can we make engineers more caring about performance without saying, okay, we need to put this user metrics, we need to measure them, we need to make sure that we run this every time we push to the to master and all these things. And it's really tough. It's really tough to sell this idea without actually introducing engineers to a lot of manual work. And this is exactly what I was trying to solve, manual work. I was working on a script, not in master yet, because there are some glitches that I have to iron out. The script that runs all performance tests for you locally. And to show what it does, it's better to do it on an example. So before we go on, I have to literally at my time 16:00, I ran the last test of the last feature of this script, and you can see the output. Yes, actually, some of you might have seen those tables that I post in different merge requests with measuring performance. And no, I didn't do that all by my hands. I was running those with this script for several milestones now, and it just got new features and a bit more muscles, if you wish to put it this way. So I was running things. Let me just do the thing. So I was running in production. So now I need to revert the things to development for a second. And we start the Webpack. And yes, for those who doesn't know, we do have the instructions on how to build the production ready bundle locally with your JDK. So it's in front-end FAQ, really useful thing. So start Webpack and restart Rails Web. So while the things are starting in the background, I probably should launch the thing here so that I see it. Technically, what this script is, it's a node script that can be launched with Yarn performance, at least in my local JDK, not in production yet, not in master. So Yarn performance, and it takes a number of arguments. It will be located in the folder assets JavaScript performance test index.js, and it does a lot of the things. So technically, what it does, it allows you to specify the number of runs you should be running for your for any route. It can specify several routes at the time, so that you do not need to run several routes separately. You just specify the string representing the routes that you want to measure. Let's say, for example, run 5 runs for me. And this is exactly what we are going to try now. We specify routes. Where do I take routes? For the start, I know that we have to do this probably in YAML or something, but I didn't want to introduce a new dependency to read the YAML files. So for now, I have this just plain object of routes that I'm in particular interested in. So WebID repo, WebID file, public snippet, private snippet, project, and repository. So just regular routes. And these names, these keys for the object, is what I'm going to use in my command line. Every route has a name, just to make the output a bit nicer. The URL at the moment pointing to my local instance. The CSS class of the element to wait for. This script is using Selenium under the hood, so it needs to know when to stop listening to the things. So I identify the most crucial element on every particular route and say, okay, measure everything that happens before this element is output. So Selenium will wait for, in particular, if we are talking about WebID repo route, it will wait for file with CSS class file-row-name-container to show up. And at that moment, it will consider the job done, and all the measurements gathered at that moment will be stored. And it has the parameter whether it requires login or not. So for example, for public snippet, we don't need the login. So we will measure it on the anonymous, we'll measure anonymous access. If it's private snippet, we do need to log in. So it will go to login screen first, log in, and then go to the snippet. The reasonable question is, where do we get the logins from? I have another file for that. Again, it has to be in a YAML file that is not pushed to the repository, obviously, and everybody will be responsible for creating their own like secrets.yaml or something like this. But I have our, I can publicly show this. It's in our handbook. So login password to our local GDK instances. Where was I? Right. So now technically we can say, okay, let's start simple. Let's say we want to measure public snippet route with runs, let's say 3 runs. And we just start the process. So it says public snippet at this URL. Now it's trying to understand, to figure out whether we need to log in. It also tries to minimize the glitches when one switches to the branch, and it happens in automated way. The first run on the new branch might take quite some time. So what this script does, it loads the route on, and you see like run 1, run 2, run 3. And now what we do, this is the best thing. Like this, now I'm showing you how those tables ended up in the merge requests. You just go here, copy the thing. Oh, I'm just laughing while I'm talking. That's awesome. Here you go. You just have the thing right there in the output, and that's pretty awesome, I think. But it wouldn't be. It's like, okay, one route, 3 runs. Okay, we can't have different as many runs as we want. We can also have two routes, for example. So instead of only public snippet, we can also push private snippet and do 3 runs for that thing as well. But getting back to that switch of the branches. So first run on the new branch will always take enormous amount of time. So what this script does, it still loads that first run and then discards those results. It just preheats the cache. So technically, these runs are going to be right. There is an error with logging in. And this didn't work out, apparently because I was dealing with something that I wasn't supposed to do. Let me just do private snippet alone. There is something with logging, but it does work. Like, yeah, stale element, reference element is not attached to the page document. Okay. This is one of those things that I have to fix, right? It used to work. I've tested this, but you can specify different routes, the number of runs, but this is not all. What you can also do, I will just show you the parameters that we are parsing technically. So we can specify different routes. We can specify number of runs. We can specify whether to run it in production or not, in production mode, not against GitLab, but it will, what you do only is you get to your GitLab.yaml, say for Webpack configuration, where is it? Webpack dev server enabled false. Stop the Webpack daemon in JDK, and then run the script. The script will go on, run the production configuration, run the Webpack configuration for production locally for you, run the metrics on this branch, switch to another branch. Oh, we didn't talk about the branches yet. Oh, I'm sorry. But okay, it will switch to another branch, run the production build there and measure there. So it will give you as close results to production as possible, or like comparison. The absolute numbers won't match, obviously, because technically we have different hardware locally and on the server. But it will go on and generate you the comparison in production, in production builds. And with that said, we can specify different branches. What this means, easy example from a couple of weeks ago, I think, I was pulled into a merge request to provide an opinion on performance for one code snippet. And there were different ways of tackle the snippet. So it was about loading the scripts loading the modules asynchronously. So the question was whether to load those with promises or whether to load those with async await. And does it even have any difference? Like if we load those in the head of the module or we load those on demand? And this is the perfect candidate. So we create 3 different branches, one with loading in the head of the module, one with promises, one with async await. And then we specify the 3 branches in this script using the branches. Let's do it on public snippet. Public snippet. So we say branches. Here we have the shortcut. So dot means this current branch that I am at, and then, for example, master. And we run the thing. The script is smart enough to figure out that, okay, if you have any changes on this current branch, it will run the measurements with your changes now, but before it switches to another branch, in this particular case, master, it will stash all your changes, switch to master, run all the measurements. Once the measurements on master are done, it will switch back to this branch and load those stashed changes back to you. So you won't lose any changes whatsoever. So you see, we had 3 runs for the current branch. Now we checked out master. We go to exactly the same route. Now we are loading that first run and discard it. And at some point we will have the same output, run 1, run 2, run 3 for the for master. It might take some time because things are not necessarily fast when one needs to do computing and has Zoom on. But at some point, it will be back, I hope. So yeah, here we go. Run 1, run 2, run 3, and switched back to my local branch and restored local changes. So we have all the things. Now we can again go copy the table and paste it into something. And then we have, we even have the, oops, I'm going to move the zoom bar. So we have the grouping, we have the column. So the rows represent different routes. The columns represent different branches. And then you can compare the things. What is faster, what is slower. This works with user timing metrics again. This doesn't measure the LCP or any web vitals or any other native or synthetic measurements. It's only about the particular user timing metrics that were put into the routes that you're measuring. So if there are no user timing metrics in the route that you're measuring, the table will be empty. So don't get surprised by that. Now, we can also do, as you saw, we are running the headless Chrome. We can do the same thing in the real browser. This is especially useful when you see some numbers really not matching or something fishy going on there. So you specify visual parameter, and it will do exactly the same it used to do before, but now it will fire up the real browser and it will show you. So now we are seeing the first run that will get discarded. And then we reload the things and start measuring for real. 3 runs. So technically, total, it will be 4 runs here, but the first one gets discarded. Now we completely shut down the browser, switch to master, and do exactly the same procedure once again. And this is the first, this is the situation that I was telling about. The first run on the new branch, when you switch to the new branch, takes quite some time because Webpack needs to reload all these things and rerun all the codes. So that's why we discard the first run so that it doesn't affect measurements that much. And sometimes it might take way too long and it will time out. The script will time out. But since we have this in automated manner, it's just the matter of restarting the script. This is not something I can do about because we still need to allow Webpack to actually refresh the things and rebuild the things for the new branch when you switch. In order to save some time for yourself, like make sure that all of the branches that you are testing are run with all the migrations, all the recent migrations migrated, so to speak, so that your script wouldn't fail because it won't be able to load the view. So now we have run exactly the same thing, but with the real browser with visual parameter. The same table, a bit different numbers, but that's something to expect. And the last parameter that we care about is throttle. So you can say, okay, the tests we were running now were run on my local network, but we can emulate 3G network so that we have more realistic numbers. So you just pass the throttle parameter and it will measure everything against emulated 3G connection. That's pretty much it. So as I said, I have to finish a couple of things here for it to be working stable. And in this particular case, I have to figure out why logging in failed now. But production, I was able to run tests on 2 different routes with 2 different branches with production set up right before this call. It worked out really well. And one last bit that is going to be implemented here is we will be able to specify site speed parameter. What does it mean? It will generate the site as long as you have the Docker installed, and it will just run GDK measure, and it will generate the site speed report for all of your routes, so that you would have not only user timing metrics, but also the reports from site speed for LCP and all these fancy words that we have there. And that's going to be absolutely wonderful, I think. And that's pretty much it. Thank you.
Awesome. Thanks a lot for showing and also working on that, because I believe that a lot around performance is especially around the topping how to make it as easy as possible to get to the data or have the data in front of you. And that was also my main question was, why not use GDK measure? So you answered that in the last 3 sentences. What do you think about turning it around, but rather like implementing that feature into GDK measure, so that we have one thing that we are basically promoting, one command, and then take it from there, so that you can say, okay, I want to have, because I would also love to have the same thing for LCP, have a table for it, have the automatic branch switching, etc. I think that would enhance the whole tool by a lot. And then you can simply say user timing metrics, just LCP, or full site speed, or all 3 of those. I think that would be also nice. What do you think?
That's a very good question. I was thinking about this, but first, I'm not sure how GDK measure, like I have to dive into this, right? But the problem is that here, I wanted to have a tool for myself. In the first, it started as a tool for myself when I wanted to know, like, just measure performance right here, right now. And I know how to work with Selenium, and I know how to work with Node and do these things. So that's how I started this. And in general, it makes sense because this tool is user timing centric, not the Web Vitals or generic metrics centric. So this was crucial for me because this position of mine is probably known to people who talk to me about performance. I don't trust LCP. I don't trust site speed. I don't trust those metrics because they don't tell me the real performance of my applications. That's why I opt out for user timing metrics all the time, and because those tell me the real picture. Those tell me the real numbers. And that's why I started to work on top of this idea. But definitely I can take a look at GDK measure and see whether we can incorporate this into GDK measure. Probably we can. The question is, with this tool, I see the potential of it becoming the part of our CI, where we run comparison to different branches. GDK measure cannot do that, I believe, to switch branches and do the things. So for me, I would envision this as part of the CI process, when you push to your branch, and then it runs tests on your branch and on master and tells you whether you improved performance. It is pretty much on the same level, or you screwed up something. To me, this tool is much easier to implement into our CI processes. But I might be completely wrong. As I said, I have no idea how GDK measure works. I just know that it's there. I know what it does, but I don't know the internals. So I might take a look at that.
GDK measure, I'm just looking at the file and post it in the agenda. It's a simple Ruby script. That's it. It puts together like a Docker command. And
simple and Ruby. For me, they just don't match the same sentence.
So it's in reality just putting together a schedule Docker command based on the parameters.
That's the reason why this solution pulls in Selenium as the JavaScript dependency and not using the Selenium that we have in Ruby somewhere. So the driver is all in JavaScript and Node for this purpose. So, but yeah, I will take a look at that simple Ruby script.
On that topic of running this in CI, one of the things that we've tackled in the past is the variability of the runs, because you can run it once, it gives you a number, you run it again, it gives you a different number. Do you think that this solution would be less vulnerable to those fluctuations?
That's why this tool supports parameter to say, okay, we want to have like 3 runs or 5 runs. Locally for myself, I always run five runs, and this gives me pretty stable picture in terms of comparing 2 things right here, right now. They do not provide you with the correct picture if you're relying on the absolute numbers. No. This is as good as comparing this branch to this branch, for example, or this route to this route, right here, right now. And as long as I'm concerned, the testing environments for both will be the same here, and the numbers, like we can increase the rounds to 10, for example, to have really like reliable, more or less reliable way of measuring the things, because then average will be more adequate, right? But it's a bit too much, I think. With 5 runs, usually we will be able to get comparable numbers if we compare 2 branches, for example.
The QA team is running already SiteSpeed as a CI tool, but not in CI itself, especially due to that, because comparing 2 different branches can be very difficult to see. And I also had this locally on my machine. It was like, oh, why is this not improving? And I was looking at the stuff for half an hour, and I simply ran it again and figured out in the background, macOS was updating 2 applications, and that was basically killing my CPU on it. So,
well, yeah, we won't be protected from things like this, no matter what tool we are using, right? This is what we can do.
That's not completely true. If you look, Speed Curve is a third-party. Sorry to interrupt you, but this is very important because there's a reason why they promote synthetic metrics and user metrics. They serve completely different purposes. So I think we could use systems where we have stability of hardware and other parameters for synthetic metrics, and then what you are promoting for user metrics, of course, can be different. But the point of user metrics is having data from real users, not CI jobs.
That's true. However,
I mean, partly right, not 100%.
Only partially.
It's also good to have.
And also about this speed curve, like keep in mind that any third-party service providing the performance measurements, they have dedicated infrastructure for running these things.
Yeah, exactly.
As long as you take that application to your machine, it will be exposed to exactly the same problems that we're discussing now, like updating macOS or anything like this. So the question here is only, so those services are prone to exactly the same problems. The problem, the good thing about them is only that they earn money with this, so they make sure that their infrastructure is not affected by these things. However, again, if we say that we, in the short period of time, like the automated script that I just showed, we measure 2 branches in the short period of time, the probability of interference like this gets really low. So if we're talking about just comparing one branch to another, like whether numbers match or higher or lower, that this is good enough. If we say that we have to rely on these numbers for a production purpose of saying, okay, we have the problem with performance because I measured it locally and the numbers went up by 50%. This is not going to work out. Now, this is for comparing 2 things right here, right now. If we take the same measurement, if we run exactly the same command in 10 minutes, the absolute numbers will be different. Yet the comparison between these 2 branches should still remain the same, more or less, than it was 10 minutes before. But the absolute numbers will completely be off, obviously.
Do you plan to have some statistics about it, like really running the measurements, I don't know, in a certain after 10 minutes, 30, and then see if the comparison stays equivalent between the different moments?
No, I don't see point in that. Like running this over time in general. So I can
no, not in general. Like you just said that we don't care about absolute numbers, and we should look at the difference between the two branches, which I totally understand. But also this affirmation could be better, how to say, better absorbed if we have data about it, and not in CI, just try to understand if it's a true statement or not. So if it's real that if you run this now, the absolute number will be different from 10 minutes before and 10 minutes after, but the which I also tend to agree, but it would be nice to know if it's if this stays true, right? So just having some data about it.
Well, I definitely didn't think about proving it this way. This is an interesting point. However, I still believe that if we run exactly the same command, like the deviation should stay within perceived 20% difference. The comparison between two branches 5 minutes ago and comparison between the same branches like 20 minutes from now, the difference should stay within perceived 20%, in my opinion. And from my local testing, that's true. But making it like public, well, I need to just run number of tests locally to prove this. But in general, this is an interesting thing. I don't know whether we should really make this make it really like this is true and this is so, because as I said, any tool is prone to things like this, to deviations like this, and the same thing for speed curve, the same thing for site speed. If you run it in 10 minutes, you will get the different numbers, and if you compare different branches with those tools, you might even have larger deviation just because the period between testing one branch and another branch will be different, because you will need to switch to another branch, do some tests, and then the deviation might be even bigger, might be even smaller. I don't have any proof for that.
Dennis,
but I just
sorry to cut you off there. I just wanted to bring something very topical to what you're saying, which is I guess we'll have to test it, because the performance marks are different than the other measurements, because they're very specific to the app you're building. And the theory, in this theory, so Angelo, I get your point that we should confirm those numbers. I think that's definitely an exercise if we're writing an article on this to get those numbers. But if you just prepare this to run in the CI, run as a sample to take some metrics and to see the variability of it, will be much more useful. Because if the resources are variable, like not enough, the different kind of memory, different kind of CPU, like Tim was saying, a lot of it will be affected. The backend requests, if we do have them in the test, will be affected as well. Here, we're affecting just sometimes between those two marks, which is just basically rendering front-end parts sometimes. So it will change per mark. Some mark might be affected, other marks might not be affected. So we definitely need to just get a sample proof of concept, get it running on CI, get the numbers, and then look at them, I think.
Keep in mind also that we already do run user timing metrics in sort of comparison mode. So we have the dashboard. We have several views now that use user timing metrics, right? Web ID, snippets, MRDiff. And those metrics are gathered with our site speed reporting, and they're output in our dashboard. And our dashboard shows that the deviation, as long as the hardware is the same, the deviation is not that much, unless something really happens in the source code that puts the marks up or down. And this is already a good proof of the fact that if we run the user timing metrics on at least the same hardware, yeah, the dashboard that Andrei is showing. So now we clearly see that something has happened and the numbers went up. We cannot say that they went up by, for example, specifically 1 second, 1.35 seconds, right? This is not about this. It's just to monitor, okay, the numbers went up and we see that this is the thing. Before that, they were more or less on one level. And this gives me a feeling that we actually can rely on user timing metrics for our measurements, and in particular in this particular script. So that's, I don't know, maybe I'm just overly optimistic. I don't know. I just
I look forward to seeing a proof of concept running on CI. Tim, you want to say something? Sorry.
Yeah, I think it's performance measurement and improvement is always around tons of data and improving a little thing here, a little thing there, and seeing improvements over all numbers. We have clearly seen this also, that we had great numbers, for example, on the measurements that we were doing, but still everything felt slow because we had a problem that the unloading was captured by the analytics and was blocked by 500 milliseconds. So, and this of course made everything slow, and this happened on unload and not onload. So this was never measured or was never felt. So a lot of manual things and need to go into consideration also on the different types of routes. What do we want to show? Do we have a great LCP but not showing any real content? Doesn't help you that much. Then we need the user timing metrics. But we also have, I believe, a lot of routes which are mainly about getting something on the screen as rendered as quickly as possible, in the sense that they can see that something's there. For example, the MR view or the boards. They are both topics where we are currently, the boards are very slow based on measurements. Why? Because we are starting to load the wrong column first, and the slowest column is loaded last, for example. So the one that is still changing for a very long time is what is still open, because that query takes a long time. And I think it's always about going in, having a lot of information. And I've seen also that performance improvements happened for the loading, but then you had huge CPU timings and everything was blocked. So we can't break it down just to one number. I was also asked that question is, what can we put in as a KPI? Which route, which number? I was like, we shouldn't put in one route of a product that has hundreds of routes in reality, with tons of different use cases. And for example, what we see on the MR on source code is the perfect example. You can have, for one route, 20 different use cases that are happening, from itty bitty tiny merge requests with 3 files and 2 comments. Yeah, perfect. That should go fast. But you can have also the fully automated ones that are putting in 1,000 different files, and that totally depends on how the users are using it and what we focus on first on improving. And then we need to go in and figure out what is the highest priority there, and what is actually the use case we want to improve first. Bringing everything together, any tool, any data that we have, I think that's the main goal that we should have, to constantly improve. And if we are changing something and it doesn't change at all, or we don't see any improvement but see it on another number, awesome, perfect, we take it. So I think that there are, at the moment, I am not too much afraid of specific timing. Why? Because the differences are still huge. We are not talking about squeezing 20 milliseconds or 25 milliseconds out of the system. We are still talking a lot of times around 2 seconds, 3 seconds, 4 seconds. And until we are not getting down to the 100 millisecond performance improvements, which I hope that we do at some point, then just take a rough number. If it's totally the same or not, then go with it. the problem that I rather see is going back to the measurements, and right now site speed instances are doing user time metrics, is that we see, based on the different types of routes, we see different types of performance changes during the measurement. So when I will give you just site speed dashboard. So what I mean with this is the following, is that you can have, for example, I think here you can see the best, that were the routes that we were measuring mainly over the last quarter. And what you can see here is that a couple of them, for example, the project homepage, has a much higher fluctuation from their timing. So you can see that we are going sometimes in a couple of hours between 2.4 seconds up to 2.8 seconds, which are around 400 to 500 milliseconds. You can see the differences in measurements, which is a clear sign based on the infrastructure that we are having a topic. In reality, what you should see is like a clear line, a deployment that goes up or down. That means that your infrastructure has enough buffer. And the worst and the biggest difference where you can see this, so the issue list is quite stable overall. But if you look, for example, at the MR list, this is really a difference in a couple of days between 2.5 seconds to, oh, that's not too big. That was the wrong one. There was another one. Where we saw a huge fluctuation of almost 600 to 700 milliseconds, even if there was nothing deployed. So that is also something we need to figure out on the other end, on infrastructure and such topics, to see what we can improve there. Good. Any other comments? Then thanks a lot, Denise, for showing everything, and also all the work that you have put in there. And thanks a lot, everyone, for joining, and take care. Have a great week, and see you soon in another call.
Thanks. Bye.
Bye.